Just wanted to let you know that you are amazing, special, and capable of anything. Thank you for watching this video and taking a positive step for your learning. Today we're going to be looking at the areas of kites and rhombuses. So, hopefully you can see on the board we have got a kite and we've got a rhombus. So maybe when you were little, or now, I'm not saying you have to stop flying kites, you would have flown a little kite. What's special about kites is that it's got a right angle here in the middle. That kind of square here means it's a right angle. And these dashes symbolize that these two lengths, so these adjacent sides, oh look how it goes to my laptop's my eyes. These two adjacent sides are equal and the bottom two adjacent sides are equal. But how do we find the area of them? Well, the first thing we need to notice is that, see this I've shaded here. Imagine if you take it off and you plug it in here. Now do the same with this side here. I'm going to do it in green. And you plug it in here. Hold up, can you see that I've made a little bit of a rectangle over here? It's pretty cool, huh? So the area of this rectangle is the base, which is this length across, let's pretend that's y, times half of x. So if the whole distance across here is x, the area of our kite is half of x times y. And the same thing actually applies to rhombuses. Rhombuses are quadrilaterals which have parallel sides of equal length. Alright, so the area of a kite or a rhombus is half x times y. That's pretty much it. So if they said, oh, you know, this length is 2 going up and down, and this length is 4 going left and right, the area of that rhombus will be half times 2 times 4. Half times 8. I don't know why I wrote half times 8 again, but that's 4. Don't forget your units though. Centimeters squared. Hopefully that's not too bad so far. Next up, we're going to look at trapeziums. This is a trapezium here, voila. And it's a bit tricky, so I like to remember with a song, half the sum of the parallel sides. These are the parallel sides, and half the sum means adding. And times the height between them. That's the way we calculate the area of a trapezium. I'll put the song at the end. I won't sing it here. So let's actually practice. Pretend B is, that's a highlighter, so don't pretend with that. Pretend B is 4 and A is 7 and the height is 4. So half the sum of the parallel sides, should have picked better numbers, regrets, times the height between them. So this is half of 11 times 4. Half of 11 is 5.5 times 4. Oh, this whole thing's in millimeters, by the way. You'll see why I'm doing that. And the answer to that is going to be 22 millimeters squared. Let me double check if I'm right. I think I am. 5.5. Oh, my calculator's all like, good. 5.5 times 4. 22. I'm a genius. What can I say? I should be like a math teacher or something. Alright, so let's do some practice here. Ooh, look, we have got a rhombus. So remember, rhombuses is half times x times y. Half times x, which let's say this length down is the x, which is 8, times y, which is that distance across. Ooh, that's fun. Half times 40, which is 20 meters squared. Don't forget your units, please. And we've got a kite. Woo! That was me flying a kite. You guys saw that, right? All right, so for the kite, same thing. Half x, y. Pretend this is the x and this is the y. So this is half times 10 times 20. Half times 200. And 200 divided by half is 100 centimeters squared. Boom. Let's look at the next one. What? It's a trapezium. Half the sum of the parallel sides times the height between them. Done. I should put millimeters. Alright. So half of 3 plus 11 is 14. Put a bit of an American accent there. Times 5. So let's do half of 14, which is 7, times 5. And that's 35 millimeters squared. So hopefully after this, you're feeling a bit more confident with how to get the area of kites and rhombuses and trapeziums. And now I gotta stop the video.
Half the sum of the parallel sides times the height between them. That's the way we calculate the area of a trapezium. Add a little bit of spice. Half the sum of the parallel sides times the height between them. That's the way we calculate the area of a trapezium.